Warm greetings to all. This is Kavita Saxena teaching Chapter 9 Heat Budget, Temperature and Solar Radiation of Class 11th Geography textbook to you. In the first episode of this chapter, we dealt with the concepts like insolation, that is incoming solar radiation. We also did the importance of insolation and established relationship between the angle of incidence of sun's rays and the intensity of heat received from them at a place. And children, I believe you must be knowing after the first part that why the sky looks blue and the setting and the rising sun looks red. We also did the different process involved in heating and cooling of the atmosphere, such as conduction, convection, radiation and advection. In part 2, you will learn the following concepts. Differentiate between solar radiation and terrestrial radiation. Explanation of the heat budget with the help of a diagram. And the latitudinal variation in net radiation balance. Now let's start with the topics. What is terrestrial radiation? The Earth's surface, after being heated up by the insolation, starts to radiate energy to the atmosphere. It is in the form of long waves. The long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and other greenhouse gases. Thus, the atmosphere is indirectly heated by the terrestrial radiation, whereas the sun radiates its energy in every direction into space in short wavelengths, which is referred to as solar radiation. The energy received by the Earth's surface in the form of short waves is termed as incoming solar radiation or insolation. The heat budget of the Earth. Everyone makes a budget for their house, which is the statement of income and expenditure. Now, there is one statement for the Earth. Earth also has an income and expenditure in terms of radiation. The Earth as a whole does not accumulate or lose heat. It maintains its temperature. This can happen only if the amount of heat received in the form of insolation equals the amount lost by this Earth through terrestrial radiation. This balance between the insolation and the terrestrial radiation is termed as the heat budget or heat balance of the Earth. Now let's see what exactly is the heat balance. The amount of insolation which strikes the top of the atmosphere is 100 units, let's say 100%. Of this, 27 units are reflected by clouds, 6 units are scattered and diffused by dust particles in the atmosphere, and 2 units are reflected back by Earth's surface as short wave radiation to this space. Thus, 35 units of short wave radiation do not reach the Earth's surface and is described as the albedo of the Earth. You can also see the presentation of albedo diagrammatically. Albedo is an important property of a surface because it measures how much incident solar energy will be absorbed. A surface with a high albedo, such as snow or ice, like 0.45 to 0.95, reflects much or more of the solar radiation and absorbs only a smaller amount. Whereas a surface with a low albedo, such as black pavement, which absorbs nearly all the incoming solar energy. The value of albedo will be different for different structures such as snow, forest, soil, black pavement, etc. Besides, 14 units are absorbed by atmosphere. Only 51 units or percentage of solar wave radiations are received and absorbed by the Earth's surface. After the absorption of solar radiation, the Earth emits the energies in the form of long waves. The Earth radiates back 51% in the form of terrestrial radiation. 17% are radiated to space directly. The remaining 34% are absorbed by the atmosphere. 6 units absorbed directly by the atmosphere, 9 units through convection and turbulence, and 19 units through latent heat of condensation. This is all very clear in the diagram given here. 48 units absorbed by the atmosphere, and the breakup of 48 is 14 units from insolation and 34 units from terrestrial radiation. They are also radiated back into space. Thus, the total radiation returning from the Earth and the atmosphere respectively is, when you total it out, 17 plus 48, that makes 65 units, which balance the total of 65 units received from the Sun. This is termed as heat budget or heat balance of the Earth. This explains why the Earth neither warms up nor cools down despite the huge transfer of heat that takes place. A significant amount of heat is absorbed by the atmosphere. This is the basis for the greenhouse effect. This word is in vogue nowadays. In the greenhouse effect, shortwave solar radiation passes through the atmosphere and reaches the Earth's surface where it gets absorbed. When the radiation is re-emitted by the Earth, it is now in the form of long wavelength, infrared radiation, which does not easily pass through the atmosphere. Instead, this infrared radiation is absorbed by the atmosphere, particularly by the greenhouse gases, such as carbon dioxide, methane, and water vapor. As a result, the atmosphere heats up. Without the greenhouse effect, the average temperature on the Earth would be about minus 18 degrees Celsius, which is too cold for liquid water, and therefore life as we know it could not have existed. There is a great deal of concern about the greenhouse effect across the globe, not because of the presence of the effect itself, but because the effect is intensifying, causing climate change or global warming. Since the Industrial Revolution, the atmospheric concentrations of the major greenhouse gases, particularly carbon dioxide and methane, have increased dramatically due to industrialization, the burning of fossil fuels, and deforestation. Now, let's do an activity on heat budget. If you can see, there is a satellite image of lower troposphere, which shows you the blue and purple colors representing the areas of lower solar energy and the red color showing the areas of higher energy. Can you tell us why this pattern is evident on the map? For more of these maps, you can visit this site www.ghcc.msfc.nasa.gov. It will give you an idea about the heat which is radiating down through the different layers of the atmosphere. After studying about heat budget of the planet Earth, let's know more about latitudinal heat balance. Although the Earth as a whole maintains balance between incoming solar radiation and outgoing terrestrial radiation, but this is not true when we observe at different latitudes. The amount of insolation received varies from latitude to latitude. Some part of the Earth has surplus radiation balance, while the other part has deficit. Regions within the equator and 40-degree north and south latitudes receive abundant sunlight, and hence more heat will be gained than lost. Hence, they are energy surplus regions, whereas regions beyond 40-degree north and south latitudes lose more heat than that gained from sunlight. Hence, they are energy deficient regions. This is because of the slant sunlight and high albedo of polar regions. Going by this logic, the tropics should have been getting progressively hotter and the poles getting progressively cooler. But such is not the case. The surplus heat energy from the tropics is redistributed polewards, and as a result, the tropics do not get progressively heated up due to the accumulation of excess heat, or high latitudes getting permanently frozen due to excess deficit. This transfer of surplus heat from tropics, which are also the energy surplus region, to polar regions, which are energy deficient regions, is being performed by atmospheric and oceanic circulations such as the planetary winds and the ocean currents. Most of the heat transfer takes place across the mid-latitudes, which are between 30-degree to 50-degree north and south in both the hemispheres, and hence much of the stormy weather is associated with this region. Thus, the transfer of surplus energy from the lower latitudes to the deficit energy zone of the higher latitudes maintains an overall balance over the Earth's surface. After going through this part 2, there are few new terms which you have learnt. The first important term is the heat budget, which is the balance between the insolation, that is incoming solar radiation, and terrestrial radiation, which maintains the heat on the planet Earth. Latitudinal heat balance. It is the transfer of heat from lower to higher latitudes by winds and ocean currents to counter the imbalance created by insolation at different latitudes. And the most important term, which is everywhere in the world, that's global warming. It is a worldwide increase of atmospheric temperature due to depletion of ozone layer and an increase of carbon dioxide content. After going through this part 2, I hope you will be able to differentiate between solar radiation and terrestrial radiation. Explain the heat budget of the planet Earth with the help of a beautiful diagram. You can also explain the latitudinal variation in the net radiation balance of the Earth with the help of a diagram. After going through this episode 2, let us evaluate the equilibrium between the terrestrial radiation and the insolation is called as the heat budget of the Earth. If the incoming heat and the outgoing heat are not balanced, then Earth would be getting either gradually warmer or cooler. So you have to select the correct answer out of these 4 options given. As far as the long answers are concerned, you have to write a long answer on the heat budget of the Earth with the help of a diagram. And the last question, examine how the anthropogenic factors are impacting the heat budget of the Earth. There is one diagram based question as well. You have to study the diagram given on the right hand side carefully, and you have to answer the questions based on insolation. You can even draw a pie chart to show one part of your answer. I hope you have enjoyed the topic. Thank you.